directly to on the chat box. Okay. But make sure that you understand whatever we are discussing about it. And if you remember last time, we started with regression, that's equal to alpha plus beta x plus error term. And today we will go ahead and we will move further in this particular discussion. Last time also we talked about correlation and we tried to understand the difference between correlation and regression. Both are required, both have different purposes, and both are for different research design. Correlation is for relational research design, and the regression is for causal research design. Okay, so no questions, then we can proceed further. Let's see what next we are going to talk about. Next thing which we are going to talk about is multiple regression model. Instead of one independent variable, now we are going to have a number of independent variables. And if we have that number of independent variables, then this will be your generic regression model. One dependent and more than one independent variable. As usual, alpha is the intercept and betas are slope coefficients of the corresponding variables. And epsilon I is your error term, which behaves in a stochastic manner and a random manner. We make by and large same assumptions which we had for our simple classical regression model, except one. We are still assuming that error term is having zero mean. Sorry. We are still assuming that the variance of the error term will be constant. We are still assuming that error terms are not correlated. We are still assuming that x and the error term is not correlated. We are assuming that error term follows normal probability distribution. We are assuming that all x's are given to us and there is no high degree of correlation between x's. So these are the assumptions which we are making for our regression model. Okay. Any questions about the assumptions if you have? And the method of estimation is OLS. So friends, we shall be using OLS to estimate our multiple regression model. So let's take an example, and that example is studying the relationship between the salary and the average performance rating, experience, and the certification. And I will be doing it again on the Excel so that everyone can understand it. Excel, I think, is a software which is with everyone. So let me take the salary data and see how do we do it. So we go to data as usual, data analysis. And in that data analysis, we will be picking up regression. All the options are arranged in alphabetical manner. my Y is salary, and my inputs are these three variables. In Excel, you can do the simple regression. You can also do the multiple regression. The only condition in Excel is that all independent variables should be adjusted to each other. There should not be any blank column, or this independent variables should not be separated and shown separate in different places in the sheet. So labels are in the first row, and then we say okay. So I increase my, that's my, right. So my model is salary is equal to alpha plus beta 1 performance plus beta 2 experience plus beta 3 certification plus error. This is the model which I'm going to estimate. What we assume that salary of a person depends upon the performance rating of that person, experience of that person, and the number of the certification that person has. The estimated model which we get is as follows. This is salary is equal to, I'm taking up to 2 decimal places, 32.92 plus 1.06 performance plus 0.325 experience plus 1.30. That's my estimated model. What next we have to do, we have to understand the interpretation of these parameters which we have estimated. What will be the interpretation of these parameters which we have estimated in our model? So let me start with this 1.30. Anyone like to respond? What is it? What does it mean? How do we interpret this? Dr. Annapurna, can you try? Aina? Anybody? Getting result is not that difficult. Interpretation of the result is where you can use your skill, use your knowledge and experience. Anybody, what is 1.30? No? Okay. The interpretation of 1.30 is that keeping preference, keeping experience constant, if certification increases by 1 unit, salary will increase by 1.30 unit. That's what it means. So for example, if I take a person A with the rating of 20, experience of 10 years, certification 8, B 20, 10. Certification has gone up by 1 unit. In that case, you will find the salary of B will be higher than the salary of A by 1.30. That's how we understand this. Similarly, 1.06 means keeping experience constant, keeping certification constant. If rating of a person increases by 1 unit, salary of that particular person will increase by 1.06. Okay, so that's what exactly these coefficients are, conveying to us the meaning of these coefficients. And when preference rating is 0, experience is 0, certification is 0, persons are still getting a salary that's equal to 39.92. Okay, so that's the interpretation part of the estimated equation. Now let's look at the hypothesis testing about the coefficients. The p-values which we get here, null hypothesis is all are equal to 0. Alpha is equal to 0, beta 1 is equal to 0, beta 2 is equal to 0, beta 3 is equal to 0. All parameters are equal to 0. That's our null hypothesis. Rejected. That means my intercept is significantly different from 0. Rejected. Performance rating. That means my performance rating is significantly impacting the salary of a person, and that too in a positive manner because sign of the coefficient is positive. Similarly, experience is coming to be significant and certification is coming to be significant. All variables are coming to, all coefficients are coming to be significant, and that means there is and all are having sign positive. That means all variables, performance rating, experience, certification, all are having positive impact on the salary. That's how we interpret this. Okay. Significance of F. Null hypothesis for F. Anybody remembers? What is the null hypothesis for F test? Null hypothesis for F test is that the variation explained is not significantly different from variation unexplained. And it is coming to be significant. That means model is explaining variation in salary in a much more significant manner as compared to the other, as compared to a situation where we are not considering any model. So model has a great explanatory power, and that's why your F is coming to be significant. R square is good. F is coming to be significant. All coefficients are coming to be significant. That shows our model is a good model. So model is a good model. We understand the interpretation of it. Any question, if you have, anybody? Gajendra, Aina, Dr. Rahul, Paradamma Reddy. Okay. So I hope all of you understand what you're talking about and there is no question. Okay. But I have a question for you. We have salary, right? And I regress salary with, say, experience. and I get some result. Then I decide, okay, let me add one more variable to it, and that variable is, say, performance rating. So when we add a new variable into our regression model, can you imagine what does it really do in the model? How it impacts my results, and what is the dynamic which is working at the back of it when you go on adding a number of variables. Just think. Anybody? I think I didn't say to all of you that start with a positive energy, and that's why you are not getting energy. Gather energy and try to think, try to respond. Let's get deeper into multiple regression and try to understand its dynamic, what exactly it goes at the back of the multiple regression. Okay? Let's understand multiple regression model through Venn diagram. So we have y and x1, one variable, and this area is something which is explained by x1. So you have salary and experience and this is what is explained by the experience, that what is this shaded area represents. If you add a new variable into it, say performance rating, a new variable, what will happen? I hope all of you have some imagination power. Why don't you use that imagination power? What will happen if you add one more variable into your model? Aina, are you there? Dr. Annapurna, Abhay, Praveen, Reena, Alka, Gajendra, Dr. Padma. So many people are there, I don't know.
Yes, sir.
You hide a variable, what exactly happens? What it does?
Sir, I think we'll have to, the model will change and
Model will change, results will change, of course, no doubt about it. But what will be that change? Can you imagine?
no, sir, that I cannot say.
This is the area which is explained by the x1 of y. And if I add another variable into it, x2, then what's x2 supposed to do? That is something which you have to do. x2 tries to explain that part of y which is not explained by x1, and through that which is not there already in x1. What does it mean? What does it mean? Salary. Experience. This is my explain part. If I take another variable, rating, I think if I take another variable, rating, now see what rating is doing. Rating will explain this part. The new variable which we added will explain that part of salary which is not explained by experience. And whatever common is there, this is my common area between rating and experience. It is already used, we will ignore it. Then what it will do the following, that this part of the rating will explain this much part of the salary. Please understand, it's a very finer point, and if you appreciate it, I tell you a lot of things you can understand. So devote time, devote some concentration here. If you have dependent and one dependent, one independent variable, and if you add another independent variable into it, the second independent variable, you know what it does? Whatever is already explained, that will be filtered out. Whatever is remain unexplained in Y or the salary in this example, that will be explained by that part of rating which is not in common with experience. So uncommon of rating, uncommon of salary with experience. Then if you regress this, you will get the relation between the salary and rating. Why I'm telling you this? I'm telling you this to appreciate role of, sorry, just a minute. To appreciate the role of control variables. Many of you are doing research, many of you have already done research. They must have used or they are using control variables. Why they use control variables? Can any one of you explain to me? What is the purpose of having control variables? Why should we use control variables? Anybody? Why should we use our control variables? Anybody? Why should we use control variables? Anjali, people are worried about your quiz and assignment. They're not worried about the session. Session से
I'm
कुछ
just
लेना नहीं है उनको.
I'm just requesting all the participants to just keep their questions restricted to the session. The assignment and other things can be discussed in the Telegram group or through email.
I mean, I'm really surprised. People are using control variable and nobody is telling me why they're using control.
Sir, excuse me, sir.
Yes,
Control is the using by good work.
but why control variables make your work good?
So the field of the work is good working and hard working to use to control.
How do you pronounce your name? Chaduling,
Sir,
how do you
sir.
pronounce your name?
And Chudalingaya.
Chaduling,
Chudalingaya.
Chodilingia. Okay. Why do we use control variables? You said to make our work good, but what is there in the control variable that make your work good?
But control is the standard work and standard position working.
But why it is a standard?
Standard is the so good working.
Yes, but why it is good? Nobody is giving me answer for it.
Good is the good work is the human being human being work.
Right, that's true, but why? Why is it that?
Pardon, sir?
Why is it that? Just a minute.
Sir, to reduce the impact,
Reduce the impact of what? Pallavi, what?
sir, of the things which are not unnecessary, or which are the questions which are not, sir, it may be related to the questions which we are not framing or we are not asking.
Yes.
Means extraneous
Do you
variables.
think by introducing control variables in the regression model, you're able to take care of it?
Pardon, sir?
Do you think that by introducing control variables into your regression model, you can take care of the control variables?
Sorry, sir, I can't answer.
Sir, I want to say something regarding this question.
Yes, Keshavji, please go ahead.
We should use control variables because control variables are in normal conditions, natural way, and we can compare our result data in a better way in to compare with control variables.
But why it is in a better way? That's my question to all of you. What makes it good?
Sir, because they can affect our study.
Pallavi, are you doing research?
No, sir.
Have you done?
Sir, I was doing, but due to my medical conditions, I have dropped it.
So what was the topic?
Sir, it was related to human resources.
Human
resources.
But what can you share with us the research problem which you had?
Sir, the research problem was job satisfaction. One was.
Okay. Do you think you need a regression tool for your analysis?
Yes, sir.
Okay. So what are your research hypotheses or questions?
So
What are
research,
your research questions? What kind of relationship you're looking at?
I can't recall right now.
Uh, let me close it. Anybody else like to add something here? Anyone can share the problem where they are using regression or where they think they should use regression? Any research question? Okay. Let me take a very simple problem. And my simple problem is I want to establish a relationship between job satisfaction and level of salary. And normally people believe that if you pay good salary to the people, their job satisfaction will be higher. Pallavi, am I right? Normally people believe that good salary will give you higher degree of satisfaction among employees. Pallavi, am I right? Or okay. Do you think it's right to say that job satisfaction depends upon salary? The job satisfaction which we see, is it only the function of the salary or what?
Not, sir. Just it's one factor. That's all.
But I don't want to study the other factors, Peshi. Other factors may be promotion
The
policy,
environment, job environment,
job environment, promotion policy,
non-financial
organizational,
incentives, non-financial incentives,
organizational culture, all that.
and identification.
Yes, identification. So what I need from the job
Also
satisfaction.
good relationships.
Hello.
Yes,
Hello,
Good
sir.
relations.
Hello.
yes,
Social relationship, social relationship,
right.
and good equipment provide the institute by trustee,
So
educational institute and research development, teachers growth
okay.
more important.
So, right, Dr. Mehta, you are right. That means there are a number of important factors that impact job satisfaction. But my study is concerned with the salary. I don't want to study their impact on my job satisfaction. But I know they are impacting. So what should I do? I have to filter out the effect of all those variables, which is not in my study, and then find out the true relationship between job satisfaction and the salary. What I mean to say is the following. Sorry. So we have, job satisfaction. And there are so many variables which are impacting it. So let's filter out those variables impact. And suppose the variables which you are saying to me that is having this much impact on the job satisfaction. So after filtering out the effect of those variables which are telling me, then whatever is left in the job satisfaction, I want to study that by using salary. Right? So that means I would like to take that part of job satisfaction which is not explained by all other variables, which I'm calling it as a control variable, and study their impact on the salary. If you do not consider the control variables, then you do not know whether the relationship which you get between salary and job satisfaction, is it purely because of salary or is it because of some other factor? You don't know. To get an appropriate relationship between dependent variable and variable of your own interest, you have to filter out the effect of all other variables, which we are calling as control variables. And that's what exactly multiple regression help us in doing. So the moment you add, x2, then x2 will try to explain that part of y which is not explained by x1. So unexplained part of y and something which is not common of x2 with x1, that will explain y. That's what exactly it means. It means that x2 will explain the residual of y which are left after regressing with x1. Will the whole of x2 explain the residuals of y? No. Only that part of x2 which is not contained in x1, that will be explaining the variation in y, not all of y, lot of x2. Okay, then how to find that part of x2 which is not in x1? For that, you can regress between x1 and x2 and you get the residual, and that will give you what is not explained in this. So let me summarize what I'm doing. Estimate y and estimate the residuals of the same. So run this regression. Sorry. Run this regression, estimate y, and get the residual. So residual means that part of y which is not explained by x. And then what you do, you regress x1 with x2 and take a residual. So from x2 subtract x1, take x2 and take the residual of y from this equation. Run it, then you will get the true relationship between y and x2, and that what exactly your multiple regression does. Any questions? Because this is a very important point, I think you should remember it. Just a minute. Any question, friends, before we go ahead? Any doubt, any query? I think I have to restart my system. There is some problem in my system, so I have to restart it. Maybe I close everything. If it works, it's fine.
Sir,
Yes. Yes, Maheshi.
For any research problem,
Hmm.
how the null hypothesis is being selected, sir? How we decide a null hypothesis, HO?
Okay, that depends upon your research question. If you give me a research question, then I will tell you how do we do that.
Say, just I want to go through this computerization of GST.
So what is that you want to check?
So whether the people have been get acquainted with the computerization of GST or not.
Okay,
So this is the problem. So how I have to select the null hypothesis? Is
null
it be,
hypothesis means people are
HO? We
not,
decide HO, no, sir.
yes,
How
H0
is it
is
be always in a negative sentence?
normally yes. Majority
yeah.
cases, yes.
Yeah.
So
Yes.
if you are trying to see the impact of computerization on GST returns,
On
then
normally, yes, sir.
so null
So,
hypothesis will be no relation.
yeah. It is not impacted like this.
Yes.
Yeah. Thank you, sir. Thank you very much.
Any other example that comes to your mind?
This is GST. Then again, acceptance of NEP by students.
Okay. So null hypothesis will be no acceptance.
Yeah. Yes. Thank you, sir. Thank you very much, sir. Thank
Null
you, sir.
means you are nullifying the impact.
Oh.
Null means
Yes.
status secure, no change.
Yes, sir. Yes.
That's what null means.
Then the H1 is always exactly opposite to HO.
Not exactly. Say for example,
What is
I say
not there in
my
HO is H1 on, no, sir?
H naught is, say, my mean is 60, right? That's my H naught.
Yeah.
H1 could be not equal to 60.
Yeah.
It may be greater than 60,
Yes, sir. Yes. Okay.
less than 60.
Okay.
So
Other than HO.
depending upon whether you are having one tail test or a two tail test, you have to decide the alternative.
Yes. Okay, sir. Thank you, sir. Thank you very much, sir.
Very good. Thanks, Maheshi. At least you are coming forward.
Yes, thank you, sir. Thank you very much, sir.
I'm
Thank you.
pushing all the people to come forward.
Yes, sir, definitely. Sir. We
But
will try our level, sir.
This is the time when you people can interact.
Yes, thank you, sir. Thank you very much, sir. So nice of you, sir.
Thank you. Let's continue with our agenda. And
Yes, sir.
the thing, is there any relationship between age and blood pressure? Of course, you will say, yes, there is a relationship.
Okay.
And in this case, you will find
Um,
R square is so much.
Okay.
Sorry. Age is having a positive impact on it. So high R square, right? Significant. Age is having significant impact on the blood pressure of the people. Is it a good model? That's my question. Should we happy with this model? Should we feel happy that, look, my R square is coming great and my independent variable coefficient is coming to be significant? Should I feel happy with this? Then somebody suggested that weight is also very, very important. And when you added weight to your model, in that case, what kind of a model you will get? You will see that age is impacting your weight and age both are impacting your blood pressure. How to model it? That's my question. That's my question. You have blood pressure, you have weight, you have age, weight is having impact on the blood pressure, age is having impact on the blood pressure. Is that the model we should work, or should we work on the model? This one. Which is the right model? And if we have this kind of a model, then how to estimate? Any questions? Still, you can make use of a multiple regression model. The solution is you can have simple multiple regression model. And this is the result we get. The impact of the age on the blood pressure is 2.161. Impact of the age on the weight is this much. Impact of the weight on the blood pressure is this much. I mean, what exactly the multiple regression is helping you? That is something which you have to appreciate. Age is having some direct impact on the blood pressure. Then age is also having indirect impact on the blood pressure through weight. So when you are analyzing this kind of a model, you have to understand what is the direct impact of the age and what is the indirect impact of the age of the weight. And then it will give you better understanding of your problem and better understanding of the results. But you have to think about your problem and how to study and analyze that particular problem. Nobody else can do this job for you. You have to use your wisdom, your experience, your knowledge to come out with this kind of a model. Simple multiple regression. Okay. Let me take one more example. We all know that law of demand says that higher the price, lower should be the demand. Okay, so we have a data with us and we want to study the relationship between the quantity of the tea and the price of the tea. So I run regression, I go to data, data analysis, regression, quantity demanded, quantity of the tea demanded is my dependent variable and price of the tea is my independent variable. and that's the result we get. Look at this model. My model is saying that higher the price of the tea, higher is the demand, positive relationship. That is not significant. R square is low. That means model is a bad model. Why it is a bad model? Can any one of you think why this model is a bad model? What's wrong with this model? What's wrong with this model? It does not control effect of prices of substitutes. And we know that economic theory says when we discuss law of demand, all other things remain constant. That means prices of the substitutes are also constant, but in real life, it doesn't happen. So what I have to do? I have to control or filter out the effect of the price of the substitute, and that is price of coffee. Filter out the effect of the coffee price on the demand for the tea, and then study the pure relationship between price of the tea and the quantity of the tea. And that takes me to the multiple regression model, where I'm using coffee prices as a control variable. And in the regression model, what is control, what is not control, it's your call. Regression is regression. It doesn't understand what is your control variable and what is your variable of interest. But you have to tell what is your variable of interest and what is your variable of control. So I've taken a price of the tea and price of the coffee together and run the regression model. And let's see what result we get. Now you see the R square has jumped to 41%. And your coefficient of the, price of the tea, that has become negative. Significant. Now you can see what it was coming to be insignificant, and with the wrong sign, by introducing a control variable, you are getting the right sign and the significant impact. And that's the role of the control variables, and that's the role of the multiple regression. Multiple regression, I tell you, a very wonderful thing. If you want to control the effect of control variables. So go for it if you're using causal research design and you have a dependent variable and a number of independent variables. Any questions if you have? Then I have a question. Can I increase the value of R square by adding more and more variables into my model and get a better model? By increasing number of variables, can you increase R square? Answer is yes, you can. So by adding more and more variables into your model, R square will never come down, it will increase. Is that good? Should we do that? We should not stop at 5 variables, 6, 7, 8. We should go on continuously and go on adding variables and increase my R square and say and claim my model is a good model. Should we do that? Anybody? The answer is no, we should not do it. Because you know what happens? When we increase number of variables, we get high R square. That's good. We love to have it high R square. But on the other side, we lose something, and that is your degrees of freedom. So there's a trade-off between the loss of the degrees of freedom and the gain in R square. And how that trade-off should be taken care of, that is something which we have to understand. Do we have a measure which helps us in getting a trade-off between the loss of degrees of freedom and the R square? The answer is yes. We have a number, and that number is called adjusted R square. Adjusted R square is R square that has been adjusted for degrees of freedom. And here you will find degrees of freedom n minus 1, n minus k minus 1, where k is the number of variables which we are using as independent variables into our model. So R square should be understood as percentage variation explained. Adjusted R square should be used when we are comparing models with same dependent variable and different independent variables. Adjusted R square doesn't explain percent of variation explained. That's the job which is done by R square. R square does that job, not adjusted R square. What adjusted R square does, it helps us in deciding which model is a good model, 2 variable model, 3 variable model, 5 variable model. In that comparison, So friends, welcome back after the break, and let's continue with our journey. But before that, it says the best insurance policy for tomorrow is to make the most productive use of today. So my request to all of you is please, please, please don't hesitate. It's your program. You own this particular program, and I'm sure that you must be having a lot of queries in your mind. Don't hesitate. Throw your queries. You can put them in a chat box. I will continuously seeing it and definitely respond to it. And please note, there is no substitute for the hard work. Okay, so get best of the today's session. Okay, it says we remember 20% of what we hear, we remember 30% of what we see, we remember 50% of what we see and hear, and we remember 90% of what we say and do. So whatever you are learning today, maybe you practice it unless and until you do it yourself, you may not remember it for a long period of time. Because if you hear, you're likely to forget. If you see, maybe you remember, but that for a short period of time. But if you do it, you can remember it for a longer period of time, and that too with understanding. Friends, never doubt your abilities. And wish you all good, best of luck. And let's discuss something very important which we do in econometrics. I don't know why this is happening here. It says always welcome your friend, and just think who is your best friend in regression models. Can you think of who is your best friend in the regression model? Anyone? There are foes, there are enemies, there are friends, but which one do you think is the best friend in your econometric things?
Hello. Hello.
Hello? Yes.
Sir, best friend of my body language.
No, I'm talking about econometrics in the regression. In regression.
So X2,
Huh?
X2 variable.
What do you mean by X2?
I mean, whatever things undiscussed are remaining over there, X2 variable, try to make all those things clear.
Okay. You know, what is that which gives the best result in regression? Because something which gives you the best results, I'm happy with that person. Who is that? Dr.
Regression.
Roman is saying correlation. No, correlation. We don't care for the correlation.
Regression.
What is that which is giving you the best results in regression? OLS. The first time I'm learning about regression models, sir, and I can't judge which function good and bad. Okay. Yes, Parandamba ready. Okay, no problem. You know, OLS is the best friend in econometrics. And why I'm saying it's the best friend? Why it is the best friend? It is best friend because it gives me best estimates, which are called blue estimates. There is no other method which gives me the best estimates. OLS is the one which gives me the best estimates, and I love to use OLS. But what is that which stops me in using OLS? And that is my enemy, that is my foe. Because that foe is not allowing me to use my capability of my best friends. You know why I'm asking this question to you? Because OLS gives you best results provided assumptions of the models are true. If your assumptions are not true, then OLS will not give you the best results. And we feel very sorry because we could not use OLS in that particular case. We have to think something different. So I say OLS is my best friend because it gives me best results provided assumptions are true. If assumptions are not true, then OLS will not give the best results. Then we have to think something different. So that means our next challenge is what happens when assumptions of my regression modules are not true. And that is our next challenge. Recall your assumptions of the regression module. Mean of the error term is 0. That's what we're assuming. Variance is constant. Error terms are not correlated. X and the error terms are not correlated. Normally distributed. X's are given to us. That's what we are assuming. So we will take one by one these assumptions. See what happens if these assumptions are violated. And how do we know whether the assumptions are violated or not? And if those assumptions are violated, then how to take care of those problems? That will be our further discussions. Okay? Violation, we have to understand. Consequences of it, we have to understand. How to identify whether there is a violation or not, that's a challenge for us. And once we know that there is a problem, then how to solve that particular problem. So that's the way we are going to discuss our violation of assumptions in this particular session. Okay, so what happened and what are the consequences when we see violations related to the assumptions? Error term is 0, follows normal, error term follows normal probability distribution, constant, correlation, independent. These are the assumptions we'll be taking one by one and deciding what happens if my error term does not have 0 mean. Can any one of you imagine what will happen if your error term doesn't have a 0 mean? What will happen? It means that the expected value of the error term is not 0. If it is not 0, the assumption is violated. Assumption that expected value of the error term is 0 is violated. If the model does not have any intercept term, then violation of the assumption that the mean of the error term is 0 will result into biased estimate. What is the condition? That is something which you have to understand. If the model does not have the intercept, then it creates a problem. And the problem is that the estimates become biased estimates. Then what is the solution? Solution is always use intercept in your model. If the estimated model is having intercept, then there is no need to test for such assumption. Forget. And if the model is having no intercept, then you perform a hypothesis testing. Null hypothesis, mean of the error term is 0. Alternatively, it's not 0. And if you come across with this not equal to 0, then your estimate will become biased. So don't use those results. So the solution always is, whenever you are working with a regression model, always have intercept into your model. If you have it, then this violation will never happen. And we are safe. We feel good as far as this assumption is concerned. Okay? Now let's take second violation. What will happen if error term does not follow normal probability distribution? We assume that error term follows normal distribution. Can you imagine what will be the consequence if we find that my error term doesn't follow normal probability distribution? Can any one of you guess what would happen if my error term doesn't follow normal probability distribution? Yes, anybody? Can you imagine what will happen? If error term does not follow normal probability distribution? It is assumed that error term follows normal probability distribution. Sorry. We assume that error term follows normal probability distribution, and violation of it will mean that error term does not follow normal probability distribution. Beige is saying a non-parametric test. Beige, what do you mean by non-parametric test?
Sir, that we can apply in case of the probability is not normally distributed and homogeneous, not homogeneous.
Okay.
This is what I understood. I have little knowledge, sir.
No, Beige, don't say that little knowledge. People are.
Non-parametric tests work on median probably, not on mean.
But
and we can
what-
use
what
non-parametric
will
test
be-
as
what
short
will
data.
what will be the problem in my regression model? I mean, what should I do in my regression model to take care of it? Can I say my estimate will be still blue? Linear unbiased estimator, best linear unbiased. Can I say that? If it is not normally distributed, where is the problem? That is something which we have to understand. Where is the problem?
So data points are not close to line. I
No,
mean,
no, nothing of that sort. Do you see here the T statistics which we are using here? What is the assumption of the T statistics? What is the assumption of the T statistics? What is the assumption of the T statistics? Underlying distribution is normal.
distribution
the-
should be, yes.
Yes, normal. What is the underlying assumption of F? The assumption of the F with the underlying distribution is normal. When error term is not following normal distribution, nothing will happen to my coefficients. They will be still blue. Problem will be in the testing. And we may not be able to use t-test or f-test in our regression model. Its consequence is that we are not able to use t-test, f-test, chi-square distribution for hypothesis testing and interval estimation. Our estimates will still be blue. Nobody can raise the question about quality of your estimates, but people can raise question about your hypothesis testing or any statistical inference based on hypothesis testing. They question it. Can I use non-parametric here? The answer is no, because non-parametrics are normally used when you have nominal data, ordinal data, or the data of one series which is not normal. But here I don't have one series. I have dependent variable and a number of independent variables. So many series are moving together, and we don't know how to check that. Hardik Kumar is saying research data knowledge is innovative. I don't know. Dr. Rahman, the consequence is that I will not be able to make use of hypothesis testing and interval estimation. My estimates will still be blue. My estimates will be best linear estimates, unbiased estimators, but hypothesis testing we cannot do. That we cannot do. Regarding t-test and regarding f-test, that we cannot do. If you try to do it, then your results will be wrong results, because the underlying distribution is not a normal distribution. Y, X, error term. Many people understand that your X should be normally distributed in regression. That's not the assumption. That's absolutely wrong. No need to check normality of the X. Okay, we have no assumption about Y related to normality. If you see the list of the assumptions of regression model, it talks about normality of the error term. Because many times people say that your data is not normal. Doesn't matter whether your X's are normal or not, we don't care. What we care is the error term. So my assumption is about error term. And if error term is not normally distribution, then I cannot use T, F, etc. Now the question is how to know. How to know whether our distribution is normal or not. Anyone? I hope many of you must have tried to check about normality of their data. How they have done it, I don't know. Anyone? How do we check whether my data is normally distributed? How do we check that?
Sir, p-value,
P-value of what?
that variable.
Which variable?
What you do.
P-value is for a statistics, right? It
Yeah,
may
yeah. Sir.
be-
It should be less than
it may-
0.005 like
It
this.
may be
No?
chi-square, it may be anything. But
Hmm.
for testing normality, which statistics p-value we use? Nisha is saying that mean, median, mode should be same. It should be unimodal. That's right, but that only gives you an idea, but that doesn't conclusively prove that my distribution is a normal distribution. What Nishi you are talking about, that the characteristics of the normal distribution. Okay, so there are two ways to get an idea about normality. One is through basic statistics. Okay, Parandamma Reddy is saying something. You are right, but the spellings of the authors which have used, that's not correct, but I think whatever you are trying to say makes a sense. Okay, anyway. We know that skewness of a normal distribution should be 0. And the kurtosis should be equal to 3. So if you get the basic statistics of the error term and you find kurtosis is not equal to 0 and kurtosis is not equal to 3, it gives you an idea that your distribution may not be a normal distribution. Then you can make a QQ plot and a histogram. I suggest you should make a histogram. Yes, box plot can also gives you an idea, but only an idea, but that's not the correct idea. Because box plot works on the quartiles and not on the basis of mean and your skewness and kurtosis. So the best idea is you can get from the histogram. And if you have a histogram like this, and if you fit into it a normal distribution curve, then you can get an idea whether your error term follows a normal distribution or not. Please understand, these graphs gives you an idea, not a conclusion. Conclusion you can get by using test. Kolmogorov-Simonov test is one, and another is Jarek-Bera test. And the Shapiro test can also be used, but normally we don't go for such complex tests. We prefer to use Jarek-Bera test, which is based on parameters like skewness and kurtosis. Okay. Right now, I'm not going to show you how do we do it. Once we finish discussion on the assumptions, I will take you to the R and there I will show how you can do that. Okay? In Excel, you cannot do this. That the Jera-Barrick statistics, and it follows chi-square distribution with 2 degrees of freedom. And null hypothesis is distribution is normal, and if that is rejected, that means the distribution is not normal distribution. How to take care of it? Yes, friends, if you find that your data is not normal, what should you do? What
Data
should-
transformation.
Yes,
Data transformation, sir.
what kind of transformation? What
Along
kind
with
of transformation? Yes, yes, yes. What kind of transformation? Tell me. Think. Think. Yes, Ramandeep, maybe by taking log, you can convert data into your normal distribution. Reason is, if you are having a lot of extreme values, huge, log reduces that variation and bring together those extreme values. So Dr. Ramandeep, log transformation may work. I'm using the term may work, but it may not work. That again depends upon the nature of the data. So Nazrina, I think this is the kind of the transformation you're talking about. Anything else? Remove outliers. Because outliers are the extreme values, and many times extreme values make your distribution a skewed distribution. So if you
Right.
remove outliers, it might be possible that your distribution becomes normal distribution. Okay, anything else we can do? If the sample size is large, you need not to worry about it because central limit theorem come to your rescue. And central limit theorem says as your n increases towards infinity, your distribution tends to normal distribution. So if you have a large sample, 1,000 observation, 2,000, 3,000, you need not to worry about it. If you are not interested in the hypothesis testing and interval estimation, only point estimates, then forget about normality of the data. Forget. If the sample size is small, then one may eliminate any outlier in the data if it exists. It may ensure normal probability distribution, or you can use some kind of transformation, like log transformation. So normality is not a very serious problem, and many of you can take care of by taking care of the outliers, extreme values, or by doing some kind of transformation. Is that okay? Third violation. Variance of the error term is not constant. What does it mean? Let's understand it first, then I will proceed further. What we mean that the variance of the error term is not constant. What does it mean? Any one of you collected, I think Aina said, I'm working on the secondary data. Aina, are you there? Anyone working with the data? Nazneen, are you working with the data? Anyone? Dr. Ramandeep?
Yes, I'm working on secondary data nowadays.
So what kind of a data is it?
The data is about the animal-human conflict, lion-human conflict.
Which conflict?
Lion-human conflict, sir. I am
Okay.
from wildlife
Okay.
stream, so
Okay.
it is about lion-human conflict.
So, you have taken secondary data, right?
Yes, sir.
From how many organizations?
Sir, this data has been collected from Gujarat Forest Department for about 20 years.
For 20 years. Okay.
Yes.
What does it mean when I say the error term is not constant? Suppose I divide my sample into two parts. 10-year data, first 10-year data, and
Yes.
second 10-year data. Okay. I estimate variance for the first 10-year, second 10-year. If they are different, that means error term is not following same variance. It is different for different period, different part of the sample. Or Dr. Ramandeep, if you have taken, I do not know how many companies data you have taken. Suppose you have taken 1,000 observations. So if I take 4, quartiles, 250, next 250, next 250, like this, and I work out the variance for each part, and I find that the variance is not same, then I will say my assumption of error term being constant throughout is violated. Yes, 100 companies. So Ramandeep, if you have taken 100 companies data, so 25, 25, 25, 25, or 50, 50, whatever it is, you break your sample and work out the error term, variance of the error term. If that variance of the error term is same, that means assumption is not violated. If it is not same, that assumption is violated. That's what we understand when I say error of the variance of the error term is constant. Okay. Can you imagine what will be the impact of it? It is assumed that error term has a constant variance, and this assumption is called homoscedasticity assumption. Homo means same, scedasticity means same variance. It means that the changes in observations, the variation in the error term should not change. Its variation should remain constant and does not have any tendency of any kind of trend. No trend. Your data should be, your error term should be like this. Variation is same across. It should not be like this. It should not be like this. Declining. That means the variance is not constant. What are its consequences? What if the variance of error term is not constant? and that's called heteroskedasticity. What will be its consequences? Serious consequences. Your estimate will be still linear, still unbiased and consistent, but not efficient. And if they are not efficient, then they are no longer best estimates, they are no longer blue estimates. That means if there is heteroskedasticity, then my estimates will not be blue estimates. And if they are not blue estimates, I cannot claim that my results are best results because my estimates are not best estimates. Here you will find the problem, efficiency. Okay. How do we check? The estimates of the standard errors will become biased, unreliable, when heteroskedasticity is present, and when your estimates of these error term is, biased, unreliable, then any hypothesis testing you do or confidence interval you do, that will give you erroneous results, and that will create problem there. To be precise, we can have linear estimates, unbiased estimates, but not efficient, hence not. So let me summarize consequences. It will not be blue. Second, estimates of the error term estimates will be biased and unreliable. And if the error term estimates are biased and unreliable, then standard errors will not be correct. And if standard errors are not correct, then there will be problem in hypothesis testing. So we have a problem. That means heteroskedasticity creates problem with the standard error. It, make it unusable. So if we have to look for some remedy, we have to take care of that error. How to deduct it? For that, we have a number of methods, and to get a feel of it, you can make a scatter plot of the residuals against the explanatory variables or against the predicted values of y. So that will give you an idea whether you have suppose if your variance is something like this, scatter plot of the error is something like this, that means we have heteroskedasticity because here variance is less, here variance is more, not constant. So graphically also you can get an idea whether we have a heteroskedasticity or not. But statistically, we have a number of methods Widely used methods are Bruce-Pagan and white test. That's called BP test and white test. So this we will do a little later when we go to the R and start working with the R. There I will show you how this test can be used and how this test can be interpreted. How to take care of heteroscedasticity. One approach is derive consistent or robust estimates of the standard error using what is called white heteroscedasticity, consistent standard errors and covariance. And popularly it is called robust standard error. What we do, you might be wondering what exactly it does. Does it cure heteroscedasticity? The answer is no. It does not take care of heteroscedasticity. It does not remove heteroscedasticity from data. Then what it does? If it doesn't remove heteroscedasticity, then what exactly?
अभी तो सर्वर छप जाएगा इंसान समझ के सही है ना सबसे अच्छा है ना
What exactly robust error does? Standard error does. If it doesn't cure, then what it does? It does simply correct the standard errors. That's it. Because I said that whenever heteroscedasticity exists, our error estimates are not reliable estimates. So the problem is at the error. So what to do? Whatever problem is created by the heteroscedasticity, if you take care of that problem in the standard error, then we get an estimate which is called robust estimate. That means the problem of the standard error is being removed. Now I can use it for hypothesis testing and for other purposes without any problem. That is one of the widely used methods. Dr. Ramandev, I'm 100% sure you must have used robust standard errors while calculating your results. Am I right, Dr. Ramandev?
Actually, sir, I was having panel data.
So in panel data also you can use robust standard error.
I checked the unit root test, applied unit root test for stationarity of the data.
But that's a different thing. But how to know that your data is not heteroscedastic? So normally data in a panel structure is heteroscedastic because of the differences in the time, the differences in the company. So error term, to believe that it will remain constant throughout is not a right belief. So even the panel data, I do not know, did you work on Stata or some other EViews?
I applied EView.
EViews. So EViews also gives you robust standard errors. There's an option.
Okay, sir. But we didn't apply.
You could have used that. And another approach is going for generalized weighted least square method. Normally we don't use it. or you can deflate your variables by taking reciprocals or by taking log and thereby cure heteroscedasticity problem. So that's how you can do it. Most of the time you will find people are using robust estimates of the standard error to take care of heteroscedasticity problem. What if error terms are correlated? If error terms are correlated, it's called serial correlation problem or autocorrelation problem. Assumption means that the covariance between error term is 0. Today's error term has nothing to do with the tomorrow's error term. All error terms are random, independent, identically distributed. And when this problem arises, we call it serial problem, serial correlation problem, or autocorrelation problem. And this problem is more observed in the time series data as compared to the cross-sectional data. And in this case, we find that my variance will not be minimum, my estimates will not be efficient, therefore they are no longer blue. They are still unbiased, linear, consistent, but not efficient. Hence, they are not blue estimates. The estimates of the standard errors will become biased and unreliable, not useful in case of hypothesis testing. The consequences of autocorrelation and the heteroscedasticity by and large same, no difference. Autocorrelation problem is more observed in time series data rather than cross-sectional data. Even if you find serial correlation problem in cross-sectional data, we cannot do anything about it. We have to accept that. Nothing can be done with regard to that. How do we do that? One method is graphical. Plot residuals against observations or against time if the series is time series, and see whether they are positively moving upward or downward, showing some kind of relationship. Or a scatter plot of the residuals against select variable residuals, and get an idea whether series are related or series are not related. Another thing you can do, you can use run test. Run test is to check randomness. Whether the error terms are purely random or not, that you can check by using the run test, which is not a very strong, powerful test, but give you some idea. Then we have what is called Durbin-Watson statistics or Durbin-Watson test. And this is the rule of thumb which we use for Durbin-Watson statistics. That is, D is approximately equal to 2 times of 1 minus rho, which is the correlation coefficient. Right? What does it mean? Sorry. If rho is 0, then your D is 0. So we would like to see value of D around 0. Okay. If D is, if rho is equal to, D is approximately equal to 2. Yes. If rho is 0, then D is closer to 2. If rho is -1, then D will be, sorry, just a minute. If it is -1, then this will be 4. And if it is +1, it will be 0. What does it mean? It means the following. Closer to 0 means the series are positively correlated and autocorrelation problem does exist. If the series is closer to 4, that means it is negatively correlated and we have autocorrelation problem. But if it is around 2, then we don't have autocorrelation problem. But D statistics, the Durbin-Watson statistics in some cases is inconclusive. 0, 4. And it has two values, which is called lower and upper, and D minus upper to D minus lower. Zone of indecision, we cannot decide whether correlation exists or not exists in this particular range. Here also we cannot say, but in this range, no autocorrelation, negative and positive. That's how we interpret this. Other method is you can make use of Bruce-Godfrey serial correlation, LM method, Lagrange multiplier method that you can make use of. Regressors are correlated, and this kind of a problem is called multi-collinearity problem. That means we find correlation or covariance between x1 or xi and xj not equal to 0. Then we have multicollinearity problem. If the intercorrelation among explanatory variable is perfect, +1 or -1, then estimates of coefficients become indeterminate and error terms becomes infinitely large. Avoid perfect correlation among independent variables IVs. If you have variables which are perfectly correlated, even two are perfectly correlated, then you will not get the result. The software will throw them out. They are indeterminate. You can't use them. Ordinary least square estimators will still be unbiased even if we have multicollinearity. Problem will be with our standard errors. Estimates become unstable, unpredictable. That is to say, when collinearity is present, the estimated coefficients are unstable. Unstable means if you slightly change the values of the variables, the value of the coefficients will become, the change in the values of the coefficients will become large. In the degrees of significance of statistical and magnitude and size, everything will change drastically. R square becomes very high, though the coefficients are not significant. Typical of multicollinearity problem. High R square, but coefficients are not coming to be significant. No variable is having significant impact, but R square is indicating that model is explaining in a good way. OLS estimators, if their standard errors, can be sensitive to the small changes in the data. And what we do, you can check for the correlation of X, R squared, but few significant T ratios. And we use what is called VIF 1/1 minus R squared. Dr. Ramandeep, have you used this correlation matrix and VIF to check correlarity?
Sir, I have used time series model,
Right.
and on the basis of number of cases on seasons. And that model has produced dendrogram based on standard errors, and those standard errors are fixed at a certain point.
Okay.
So
But why you are getting dendrogram? Dendrogram is for cluster analysis.
I just wanted to check that
Are
is
you confusing it with ACF chart?
yeah, exactly, sir. Yes,
Correlogram.
correlogram. Okay, yes, correlogram, right, sir? Yes, sir.
Yeah.
Correlogram. So
Yes.
I'm not, sir, able to clearly read that correlogram. What does that mean if standard errors are fixing or remaining constant at a certain points? What it is telling?
No, correlogram doesn't say anything about error term. It tells about autocorrelation and partial autocorrelation. That's it. Nothing else.
Yes, that model has used moving average method on autocorrelation.
I don't know.
So
Was it a smoothing?
is that system of use or not, sir?
Was it some kind of ARIMA model or what?
Yes, sir, ARIMA, exactly. Right, sir.
So
this is a model.
So what was the issue in that?
I am not actually able to clearly read that correlogram to understand that what it is telling about.
Okay. A little divergent, friends. Just
Yes, right, sir. This kind of graph I have.
okay. So if the autocorrelation is dying out like this, that means the series is stationary series. If it doesn't die out, it remains like this, then the series is non-stationary. That's one idea you get. Another, when you are developing ARIMA model, then how many lakhs of AR and MA you have to take that you can make out from correlogram.
Okay.
Okay.
So is there any significance of putting this correlogram in research or not, sir? I mean,
no relevance.
Okay.
Because you are going to use ADF for stationarity check, right?
Yes, sir.
So ADF will prove whether your data is stationary or not.
Right, sir.
But how you have decided lakhs of the ARIMA model?
Actually, I have decided it on the basis of seasons, summer, monsoon, winter. I have created that data, 20 years data, I have divided on seasonal basis, sir.
So
And
that seasons you will introduce by using dummy, right?
Right, sir.
Seasons you can introduce by using dummy variables.
Right.
Okay, but how many lakhs of AR and MA you have taken? How you have decided that?
Sir, lakhs in the sense of 3 lakhs per annum?
No, lakhs of the variable. Y, T. yt minus 1. This is AR1.
Okay, sir. Lakhs would be, sir, so number of years.
I don't know. Are you taking quarterly data or what?
Quarterly data, sir.
We have to see that what exactly the data is, the behavior of the data.
Okay, sir. Thank you, sir. Thank you.
Right. So, friends, I don't know, anyone use this correlation and VIF, variance inflation factor for checking multicollinearity? Anyone? Okay. Correlation gives me pairwise relation, two variables at a time. VIF, you know what VIF does? Suppose I take X3, then I regress X3 with beta 1 X1 plus beta 2 X2. And then I calculate R square of it and then apply the formula and get the VIF. So VIF is more powerful because it doesn't compare pairwise, it takes the whole variables into consideration. And one variable as dependent in the regression and others as independent. Work out R square and get the result like this. And normally people say, again, as a thumb rule, not any scientific reason, if VIF is less than 10, we should not worry about the multicollinearity. Because high correlation creates problem. Low degree of correlation never creates problem. In fact, we can never come across variables in real life which are having no correlation at all. Some degree of correlation is bound to be there. Okay. What is the solution for multicollinearity? Ignore. If your objective is only prediction, nothing else, drop variables which are causing multicollinearity. You can transform the variables and you can identify underlying factors using factor analysis. That's what you can do. Any questions, friends, before we proceed further? So let me summarize. If the error term if it is not 0 and I have not have intercept in my model, then it might be possible that my estimates become biased. Solution is always use intercept, always in your model. Okay, if error term is not following normal distribution, my estimates will be still blue estimates. So I need not to worry as far as the estimates are concerned. My worry will be about hypothesis testing because the test which we use, they are under the assumption that error term follows normal probability distribution. How do we deduct it? Graphically, you can see by making the histogram and other graphs, and you can use a Kolmogorov-Simonov test, or you can make use of Jarek-Bera test. What is the way out? If your data size is large, no problem, central limit theorem will take care of it. If you can do some kind of transformation, you can convert your data into normal distribution, remove the outliers from your data, and you can get the normal distribution. If variance of the error term is not constant, then your estimate will not be blue estimates. And as a result, your estimates are under question mark. Okay, the solution is use robust error. Autocorrelation problem, serious problem in the time series, not in the cross-sectional, and you can make use of Durbin-Watson statistics to check for it. Or through graph, you can do it. Okay, multicollinearity problem, you can check by using VIF, and it creates problem about the stability and reliability of your estimates. Solution is drop those variables which are creating problem or join them together by using principal component analysis or factor analysis. So that's the whole view about the assumptions and their violations in the regression model. Any questions? Any questions, friends, before we proceed further? No? Okay. What next is whatever we have discussed so far, I have been told that it has to be implemented by making use of RStudio or R software. So I take you to that and see what syntax, what commands we use to do the necessary regression analysis. So I don't know how many of you are familiar.
Grammar worksheet கொடுத்திருக்காங்கங்க. Grammar worksheet கொடுத்திருக்காங்க.
Okay. So let's first do with the simple regression. I don't know why it's not working. Right. So let's first do for the simple regression. So I have a CSV file. That CSV file you can read by using this command. Read.csv, and file I have to choose from a particular directory, and header. The first row in that file is a header. So if I run this equation, it will prompt me to a dictionary. And I have to select the file. So I have opened this particular file. And if you want to view this particular file, you can do that. The name of the file is D ratio. You can view the file. That the file we have the company names, we have the debt equity ratio, and we have the beta. And we say that debt equity ratio is impacting my beta because higher the leverage of a company, the risk of that particular company will be higher. So I just close it. If you want to see the structure of it, the command is str, debt equity ratio. So this variable D underscore ratio is having two fields, debt equity ratio and beta. If you want to see the data, the tail data, that the tail data at the end, and this is my head data in the beginning. Okay, so if I don't want to refer this variable again and again, I can attach it. And first, I would like to make a graph, and the command for the graph is simply plot. This is for background. That's my schedule. Simple command. Plot, and you have to write the variable's name. I can show you the command which you can have. Simple command, plot, and first we write that variable which we want to see on the x-axis, and that is debt equity, capital D, E, ratio, cover. And that's the, so if you want to add colors, etc., you can do that. But that's the simple command you have. Very simple. Plot variables name. Okay.
Sir, if want to plot histogram or bar graph, then?
Command is simple. Hist. Suppose I want to make the histogram of debt equity ratio. That's the histogram we get.
Thank you, sir.
Okay. And to run regression, we have a very simple command. And the command is LM, that is the linear model. Linear model. And my regression is a linear model. So first we write the dependent variable, then we use this tilde sign, which is below escape key. And then my independent variable. Then just run it. See the result which you get. This is my intercept. Beta is 0.885. If you want to see the complete result, you say summary result, and that's the result which you get. We get the values of the coefficients, intercept, beta, coefficient, error term, t values, p values, all those things which we get. And that's how we get the result. So in the plot which we have drawn, you want to fit the regression line. You have to just type abline the result which you get of the regression. And you will find the fitted line here. I tell you, it's not difficult to do regression in R with simple commands. You can remember easily. So if you want regression without,
Sir,
yes,
where to find these commands, sir?
I will share this R file with you people.
Thank you, sir. Thank you.
So ask the organizers to take the file from me, I will share it. Then if you want the result without intercept, you have to write -1 in the list of the independent variables, like this. And you will see there is no intercept. If you see the summary, no intercept is here, only the beta coefficient is there. And if you want to draw the line without intercept, that's how you see the line without intercept. Okay, so whatever we have done, you can save the predicted value, you can have the residuals. Command is simple, predict and residual. Predict residuals. And the result is the variable where you have saved your result of the regression model. Then you can simply plot them. Sorry, I'm not run this regression. That's it. Observe. Do you see any problem here? Do you see any problem here? Variation here, variation here. How do you see that? Variation is increasing. That means this model must be suffering from heteroscedasticity. And many times we need a standardized beta. And to get the standardized beta, we have to install a library which is called Quant PSYC, that stands for psychology. So I'm installing this package. Then run the library. Then the command is lm.beta result. This will give you the value of the standardized beta. This is the value of the standardized beta. If you have run this model, then you run the result. You will get the standardized value of the standardized beta. And standardized betas are used for comparing which variable is more important, which variable is less important, which variable is having more significant impact, which variable is having less significant impact. Higher the standardized beta, higher the significant impact. Lower the standardized beta, lower the significant impact. You can also, read data from import. Let me do the multiple regression. Right. I show you, we can also read the data from Excel file. So file, import from Excel, browse. Suppose I take this problem. Oh, this is CSV file. Okay, so let me this quantity of price and so we have quantity of tea and price coffee, price tea. Import. This is my data. This is my file which I have taken. And name of the file is, name of this data is quantity, tea and price. If you want to see the structure of it, you simply write str. That's my structure. Quantity tea, price coffee, price tea. What I do is I attach it so that I should not write it again and again. Then I get the result, and dependent variable is quantity of tea. Then this tilde sign, then independent variable, price coffee, and plus. When you write more than one independent variable, you have to write plus sign. So plus price of tea, then sorry, result is equal to 11. Then summary, result. That's my estimated model. And if you want to make a matrix of the correlation of your main database, you can use the command pairs, variable name, enter. You get the matrix of the correlation of these variables. Simple, no problem. Okay, for testing, what I do is I read if file with this salary. So import data from Excel, browse, salary data. Sorry. This is not the right file I need. File, import from Excel, browse. Sheet is salary data is my sheet. That's the data which we have. And then we say import. This is my name of the file. I just do a little thing here. I'm defining a variable salary equal to this. That's my structure. Salary annual average performance rating. So if you want to have the lower panel itself, so you can write pure salary lower panel and sorry. You will not get values in the lower panel, you will get correlation in the higher panel. If you want to see the fitted line, the command is upper dot panel is equal to panel dot smooth, and you will get the fitted lines in this. You can run the regression, same. You can see the summary of the results. That's my summary. And you can get the standardized beta. These are my standardized beta. Okay. Now let's say how do we check for normality and all that? For that, we have to save residuals. So I just defined here resid. Salary result. So if we have to download a library which is FBasic, you can make a histogram like this. If you want to add a normal curve, the command is curve dnorm, which is the curve for the normal. You can fit the normal curve. And now you can see it doesn't follow normal probability distribution. Jarek-Bera test you can do. And p-value is not coming to be significant. That means it shows that distribution is a normal distribution. And you can also use VIF for salary results. We have to install a package car. Only then I can perform the VIF. That's what we get VIF. So multicolority you can check, normality you can check, and to check heteroscedasticity, you have to install a package lmtest. Then download the library. This is the BP test which we have. That's for salary result. .7064. That means the model is not suffering from heteroscedasticity. That's how you can get. If you want robust standard error, you have to install a package which is called sandwich. Download this, and this is my salary result. Sorry. Now I get the, your robust error estimates. I think let me show you one complete exercise which you can do yourself. So I read an Excel file. It won't take much time for me. I read an Excel file, import data from Excel that you can easily do. I take multiple regression data. I have Y, X1 and X2 in my data. I import. The name of the variable is very large. It says multiple regression data. I don't want this large number. So what I do is I create a small variable name, simply data. Okay. Now I want to see the correlation among different data which we have here. So pairs, data. Let's run it. That's the matrix which you get. You can give an option whether you want lower or not. Suppose I don't want lower panel. So you can say lower dot panel, null, and you get it. To run regression, I say result equal to lm. Okay, so y and x1 plus x2
खिचड़ी बनाना
check. Okay, I think I have to attach first. Data, then I can run this model. Summary, result, enter. That's the estimate which you get. You can save the residual. Res equal to residuals.
Right.
Result. You can make the histogram of it. So friends, like this, I don't, don't be afraid of R. It's not very difficult. Commands are very friendly. And I promise that I will be sharing this file with you people. And you can do it very conveniently. The basic work of regression you can do in Excel. For advanced work and testing of hypotheses, etc., you can work with eViews, Stata, other softwares, as well as R and Python. So that's your choice. And I think we are done for the day. Any questions if you have? Most welcome. Any doubt, any query anybody is having? No?
So first we'll try to run our program, then I think query will come.
I tell you, you just you open it, you start writing those commands, it will not be very difficult. You have to be friendly with R. Don't be afraid of R.
But
Yes,
thank you
ma'am.
very much, sir, for making us familiar with the R program.
Yes, yes, yes. So thank you very much and all the best to all of you. Enjoy and have a good time.
Thank you, sir.
Thank you, Rajiv ji. Thanks a lot.
Thank you,
Thanks
sir.
everyone. Thanks.
Thank you, sir.
Thanks every participant, and it's nice.
Thank you very much, sir.
You were there, but one regret is that you people were not that, pushing me to the corner. Good. Okay, so don't think it's a beginning. It's a beginning for everyone, even for me, it's a beginning. But you have to take it long way. Don't forget, you have to go miles and miles before you sleep, and no substitute for the hard work. And with this, thanks everyone. Thanks everyone. Thanks everyone.
Thank you very much, sir.
Thank you.